begun.
Alright guys, so today, my observer's not here today, so my supervisor, she's out of town, but she asked me to take a video of this class. She wants to see how everyone's doing, alright?
Can I say hi?
You can say hi, say hi Miss Ambrose.
Hi, Miss Ambrose. Hey, what's up, girl? Hey.
Alright, so we left off yesterday watching a video, and we're gonna rewatch this video because it kind of got cut off from yesterday. We're talking today about pH, acids and bases. We talked about it in our triaps, right? And we used pH as a variable, and we changed pH of the different triaps, right? So our one had an alkaline pH, or known as a basic pH. It was a base. We had our control at neutral, which was 7. And then we had our acidic water, right? Which was, I believe it was Sandy, which was about a 5.0 pH. And so we're gonna start off with the video again, just so you guys get a general overview of acids and bases, how they fall on the pH scale. There we go. Is this on? All right.
Paper. Our stomachs are very acidic. Our blood is slightly basic. Our proteins are made up of amino acids. And the letters in our genetic code, those A's, T's, C's, and G's, are all bases. You were probably taught how acids and bases behave on the molecular level. You were probably never taught that a long time ago, like ancient Greek ago, before anyone knew about atoms or molecules, acids and bases were defined by how they behaved. Acids tasted sour and corroded metals. Bases felt slippery and could somehow counteract acids. When molecules dissolved in water interact, they're exchanging two main currencies with their surroundings: protons, also known as hydrogen ions, and electrons. Depending on how a molecule is composed or shaped, it may be willing to donate or accept either protons or electrons with some other community member. And some molecules are far more aggressive than others when it comes to donating or accepting either currency. Remember that protons are positively charged and electrons are negatively charged. So if a molecule is willing to give up a proton, that's not too different from it being willing to accept an electron. Either way, it's becoming more negatively charged. Other molecules are willing to accept a proton or give up an electron. These are becoming more positively charged. Some substances are so aggressive about donating their protons that when they get a chance, all of the molecules in a sample will dump a proton, sometimes more than one, to the surrounding water molecules. We call these strong acids. Meanwhile, some compounds are so ready to accept a proton that they won't wait around. They'll just rip one off water, which usually has 2 protons but is generous enough to hang out with just 1. We call these strong bases. Other acids and bases are not so strong. They may donate just a few of their protons to water, or accept just a few protons from water, but most of their molecules stay exactly the same. If left alone in water, they'll reach some equilibrium point, where maybe only 1 out of 100 or 1 out of 10,000 of their molecules has exchanged currency with water. As you might guess, we label these acids and bases weak, but in the common sense of the word, they're not weak. The vinegar in your salad dressing that you can smell from across the room, that is a weak acid. The ammonia you spray on glass for a streak-free shine, that is a weak base. So it doesn't take much to be an active player in the chemical economy. Most acid-base chemistry takes place in water, which can act as either an acid or a base, accepting deposits and enabling withdrawals like a 24-hour molecular ATM. And when a proton deposit customer, that's an acid, and a proton withdrawal customer, the base, shop at the same time, their net effect on water's account may cancel out, and we call this neutralization. Now, certain molecules can behave as acids or bases without water, but that's another story. Let's end by saluting water as the resilient and fair banker for acids and bases. It's always open for business, doesn't charge interest, and will never foreclose on your molecules. Which is more than I can say for wah wah.
Lights are coming on. Watch your eyes, please.
Alright, so we've been learning about the properties of water, how it's, water is known as the what? The universal solvent, right? And so water is usually the solvent for all these bases. And I say solvent because water's acids start out as salts and they get dissolved in water. And so water is a big player in acids and bases. You need water to create an acid or a base. If you don't have water, then it is just a salt. So one salt that you can get is, there's sodium hydroxide, which is a very strong base. And that's also known as lye. Have you guys ever heard about old soap? Old soap used to have trace amounts, really small amounts of lye in it. And it was supposed to help your skin, but it ended up causing a lot of very bad effects. So open up your workbooks to B6. All right. So take about 10, 15 minutes to go over B6. And then why is pH important? All right. Take some time. If you have any questions, let me know. I'll be walking around the classroom to help you guys out and talk with your partners. Get these two worksheets. Go. So. Break down what it's right?
Water is water
Basic, right?
basic.
Yes, Belma?
Right there, it says pH scale starts at 0 and ends at 50.
Yeah.
The value
Neutral. Yeah, good.
the value of 7,
7.7 would be basic, yes, so it'd be
which lies
very slightly basic, right? But like true neutral is 7. And we usually figure out
it'd be right there.
when we're talking about water, right?
But if
It's
the
usually
value of 7,
between
exactly
7 and 8 and 6. That's like
and then 6 is going to have pH lower than 7, so anything lower than 7.
so 707 would be slightly basic, right? It's over 7, right?
6.9 lower.
And then 7.0 would be
And then basics really have pH right over above 7.
Right.
So even if it's 7.1, it's not even
Alright. How'd you feel about it?
Man, pure water is 7.
What's up?
That's neutral.
How are you feeling about this?
Let's identify these. Okay, so number 1 is battery. Number 2 is water. Number 3 is also water. Number 4 is water. Number 5 is water. 6 is rain. 7 is water. 8 is also not. Myth is that is
Oh, water and healthy.
and then X is cancel number 10. solutions of 11
Be more basic, right? So, we want cell solution. Remain healthy. Right?
You just look, physics solution,
What? Acid, basic, acid, negative.
How are you feeling over here, Jackie? All right. Good? No? What's
On this? No, I'm feeling good.
Did you answer the next questions?
Very nice.
You also have the back side. Oh, I'm sorry. You okay?
Yeah.
We still got this back side. You ready?
Let's see, that was number 1, it was indicated which one it was. Okay, let's see question number 2. Oh, it's Spanish. You have an answer, remember, read number 1.
It was over 7.2.
I mean, it actually answers us right there. Well, the pH of the solution in question 2 would be greater than 7, less than 7, or exactly 7. Okay, I'm not gonna look, but I know basic is 3, so it's gonna be more than 7. If a solution is the exact same number of hydrogen H plus H positive ions and hydroxide OH negative would be if they have the same number of H plus and OH negative, would it be acidic, basic, or yeah, he definitely was going to Spanish.
What? I know. That was a typo. That was a typo. We were translating it, and I guess it got changed to the English version.
Basic,
What is it?
how would a Spanish person read it?
Yeah. So, like, when you're low pH now, so like, your certain parts of your body, and if you have a low balance, the pH shifts too much. So you tend to run from like really big.
Oh my god. If it has the exact same number of H plus and always negative, if it has one of this, yeah, but another thing about it, it's kind of water. Like, if you have one of this,
What are you talking about?
but water has 2.
we talking
Questions.
about? Right, so the solution has the exact same number of H plus ions with OH minus ions, right? Would be acidic, basic, and neutral. So think about it, right? Think about it just in terms of you have one plus and one minus. You will have zero, right? The same amount, you need that.
I went there because like the house was halfway. Yeah. What's the oh, that's about a 504.
How are we feeling about this, guys?
Good.
So that means we're average. I mean, we're failing.
Even if it's short hair. No, I don't know. I am a man. And then I know. I'm gonna say you want to go me down. No, my mom want to go me down. She can keep it. That's right. I didn't know. Listen, I put maybe the ring. I don't know. I just be. I just be letting her know, but I'm going down. It's because she's off today. So I usually, my mom told us,
Hello. We're working on
Oh, so any
I'm like,
higher or lower in the blood cell?
I mean, so, before she gets up. She gets up like but then my sister, my red
Oh, I really want to put that. Lemon juice to cook
You're right. Yeah, so why would it be neutral? Think about it. The exact same number of H plus ions plus 1 as hydroxide ions minus 1.
and
1 minus 1.
and acidic is a
Zero.
substance
No
that
charge.
trace and toxic stomach by causing inflammation. Based on this, we believe the acid is acidic or basic. Actually, that's a whole question because that's acid in the name. So you would assume it's an acid.
Yeah, I'm sure that's why you didn't think about
Got it.
This is right.
And then it's a clear thing. Because
Based on this, do you believe that anions are acidic or basic? So,
I think it's basic.
why?
Because it's supposed to neutralize stuff.
Stomach what? Yep. Supposed to counteract. Specific vitamins. So, citric acid. Yes, you need vitamins. Higher trying to help your stomach. The medication will balance Alright. Right before number 9.
I know, yeah. When they were oh yeah, it was funny, bro. I was like, bro, she's sitting down.
No, I'm not paying attention. I'm trying to like understand.
I was scared for like
Because it neutralizes things.
Okay, what's your question?
Okay, okay, I think basically I have no question for it, but if you think it's acid, why do you think so?
Yes, you're right.
In my mind. So, right here, it's like, okay, so I kind of imagine now, like, everything's like equal. But the acidic is like less than equal. And then the basic is like more useful. Okay, I'm explaining to you my way. Okay, so the way I imagine that everything is like, but from 6.9 and down, that's neutral. And then basic, 7.1 and up.
That's fine. Yes. Let's see. I believe that dishwasher is based because it dissolves break down greases, right? Alright. That does sound right. So you are right with it being basic.
Okay, this is wrong.
This one is right. So do bases contain more H plus ions or OH minus? OH Yes. So alkaline Okay, so technically water involved in 6 elements, right? But the true neutral is 7. That's true neutral. All the charges counteract each other, right?
It's because acid and
Your 1 through your 1 through 6 is
I
going to
I just sometimes think that when the answer is right there, that you guys just seconds think of it.
Who still needs more time on B6? We got 1. You guys still need more time? 2. Jackie and Mari. That's 3. 4. We're gonna go over the answers in 5 minutes. 5 minutes.
That's a little bit too long.
A little bit too long. Huh? Oh, that's for chemistry.
What do you think so?
What? I can understand it, I can read and write this. I just cannot. Why? Because you know when I'm thinking in English, translate. So like when someone talks to me, right? They talk to me in Spanish, I have to translate first.
And basically like
Jennifer.
basically like my song is
Oh, Mr. Senator Steve speaks to God as well. He's one of the subs. Yeah. One of the sub that we had he speaks to God. I know a few
Oh yeah, I know a lot of them.
You guys finish this? And I was in honors. Yeah. So, what? Spanish is not as hard as learning English. I'm gonna say that. What? English is typically the hardest one. I find Spanish one of the easiest. A lot more straightforward. So like, you have like. What? I know how to write. I read up in Spanish photos. You watch me write them. So,
Other cleaners and trained cleaners
I don't want to do this.
Ryan,
I have a video
on
of
free
it that
in
should be
person.
this guy was
Negative and that.
his whole digestion tract. So basically his esophagus, you know, he can't grab his stomach. That all got dissolved all the way down. What was his name? Oh, my dad one time got to play with that gentleman. He was a serial killer that was in Vegas. He was dressed as a pirate. No, she forgot to.
My hands would have fallen off.
Alright, did you guys finish? Alright, you guys finish? Luke, John, did you guys finish? Dr. Cole, come on, man. Dr. Cole.
I think you're gonna have
Alright, did you guys finish? You guys even moved on to that. Everyone's moving on to the next one, huh? What don't you get about it? So, acids contain more H plus ions. And bases contain more OH All right. It seems like everyone is done. Let's go over our answers here. Let's turn around. Turn around, we'll go over our answers here. So, number one, indicate if each one is an acid, a base, or neutral. Water with CO2. Acidic, right? Water in which a snail lives, which is 5.8. Acidic. Water with 2 milliliters of bleach. Basic. Coffee with water? Acidic. Water in which aquatic plants live. Basic. So this one's kind of slightly basic, right? It's not neutral. So I talked to you with a few of you about this, right? So the FDA kind of says that drinking water is right around in a range between about 5 to I believe 9. That's like safe drinking water. It's the pH. What we'll learn later is, something might have like a low pH, but it still won't be that dangerous because of the concentration. So we'll learn this later, that concentration makes acids or bases more dangerous. It's not really the pH. Alright, And pure water, which is at a 7.0. Neutral, that is true neutral. Now, we won't find true neutral water that often. It's not possible, you would have to distill water, I believe it was 4 times. You'd have to distill water 4 times to get absolutely pure water, which is at a 7.0.
So like if you go to a lake,
That won't be 7.0, right? The water in which aquatic plants live is a 7.7, so if you got a lake with seaweed in it and stuff, it might be at 7.7, might be a little bit higher, might be a little bit lower. Alright, so we have our neutralization reaction. A solution with an excess of hydroxide ions would be considered acidic, basic, or neutral? Basic, so hydroxide ions are part of a basic solution. Alright, with a pH in question 2, would it be greater than 7, less than 7, or exactly 7? Say that again? Greater than 7, right? It's going to be greater than 7, it's going to be more basic. If a solution had the exact same number of H plus ions as hydroxide ions, would it be acidic, basic, or neutral? It would be neutral, right? The same number. So if we think about it like this, alright? If it had the same number of hydroxide ions, which hold a charge of -1, and hydrogen ions, which hold a charge of +1, right? If we had 1 minus 1, so +1 minus 1, which is our -1, what's that going to equal? 0, right? So there's no charges, making it neutral, right? Alright, let's turn over to the next page. Turn over to the next page. Alright. So, human cells, the healthy person's blood has a range of 7.2 to 6.9. Would a human cell sitting in a solution with a pH of 9 remain healthy?
No.
No, why not?
Because some things have to stay healthy for 7.2 to 6.9.
Yes, right? So it can only stay healthy in a range of 7.2 to 6.9. If we go over that, which is a pH of 9, that blood would not be healthy. Alright? An antacid is a substance taken to treat an upset stomach by causing a neutralization reaction in your stomach. Based on this, do you believe that antacids are acidic or basic?
Basic.
So, alright, give me a 1 for acidic, 2 for basic. Alright, so let's look back, turn back over to our neutralization reaction here. H plus OH minus gives you H2O. Alright? H plus, if a solution has more H pluses, it becomes more acidic, right? If a solution has more OH minuses, right, or hydroxides, it becomes more basic. Alright. So if we're talking about an antacid, which is, as we know about our prefixes, ant or anti means against, and so against an acid. If it's going against an acid, would it be acidic or basic?
Basic.
Basic. There we go. Right? So, because bases cause oils and fats to fall apart, your digestive system uses bile, a basic compound, to help in the digestion of fats and grease. Oven cleaners and drain cleaners contain lye, a strong base that dissolves baked on grease and burned fats. So does lye contain more hydroxide or more hydrogen ions? Hydroxide. Alright, our OH minuses. Right? So with dishwashing detergent, be acidic or basic?
Basic.
Basic, right? Because it's breaking down fats. And I also talked to a couple of you guys about this as well. There's a rule we have that's called like dissolves like. So if our dishwashing detergent is more basic and it breaks down fats, then that must mean that fats are they more basic or are they more acidic?
Acidic.
So they would be more basic because like dissolves like. So bases help dissolve bases. Acids help dissolve acids. And you'll learn later, polar molecules help dissolve polar molecules or ionic compounds. And nonpolar molecules help dissolve nonpolar molecules, right?
Can you repeat the name of something dissolved?
Oh, so the name of our little rule here is called like dissolves like. Right? So our solutions are going to dissolve like solutions. Alright? So you guys did a great job today. In our last minute or so, Miss Santana said that we could discuss the nicknames for our frogs over there. Well, we gotta vote on it because we don't want them to get confused, right? If we're calling them. So, raise your hand if you got a nickname for our frogs here. Good.
Oh my God, wait,
Alright, Jennifer? Tony?
Timmy. Gigi.
Gigi? Blueberry?
No, bro.
What else, Danielle? How do you say that?
I don't know how to spell it.
Guadalupe.
Timmy.
Timmy? Alright, you guys have a great weekend. Stay safe.